Good news?
Yep.
Okay, now, f of negative 6. F of negative 6. Type it in. Push enter. Tell me what happens. 9 real. Why is that? Why? Okay, you're thinking in the right direction here. This is no solution. Remember, what is the base here? This is log base 10, right? So the question is this. The base 10, to what power must I raise the base in order to obtain negative 6? How can you get a negative number there? You can't. Because always 10 to some power, it has to be positive. So that's why it's going to be no solution. All right, let's get on to the graphs here, and then we're going to wrap this up real soon. I want to refresh our mems here real quick. What is the line by which we reflect a graph to get its inverse? Okay, there was a line of symmetry. There's an equation for that line. Y equals x is the correct answer. I want to look at this. I want to look at y equals 3 to the x power. Okay? Now, I don't want to spend a whole lot of time on this, okay, because this is 3-1, right? So I want to make a real quick x, y, t chart. All right, I'm going to plug in 2, 1, 0, negative 1, negative 2. I'm just going to real quick plug these numbers in and graph it real fast. All right? So if I take 3, this is not log. This is 3 to the x power. This is exponential. Okay? So take 2 and plug it in. 3 squared is 9. Take 1, plug it in. 3 to the first is 3. Take 0, plug it in. 3 to the 0 power is 1. 3 to the negative 1 is 1/3. And 3 to the negative 2 is 1/9. Okay? Fair enough? What I want to do is graph these. So there's 0, 1. Okay? There's negative 1, 1/3, negative 2, 1/9. 1, 1, 2, 3, and 2, 4, 5, 6, 7, 8, 9. Takes me right about there. And we remember what this looks like from the pop quiz and 3-1. Okay, something like this. What does log base 3 of x look like? I want to put it on the same graph. What is it going to look like? I want you to take this diagonal line through 1, 1, and 2, 2, and 3, 3, and 4, 4, and 10, 10, and negative 7, and 0, 0. It's called the y equals x line. That line crosses the origin at 45 degrees if your window is the same on the x and y axis. And what we're going to do, what you can do, take your notes and turn it diagonally so that this dotted line is straight up and down, and you're going to sort of imagine flipping this thing over here like this.
So you might never
Is that what it looks like?
Put the dotted line straight up and down. Yeah, that's log base 10 though, isn't it?
Oh, yeah.
Okay? What is happening to our numbers? Yes. Why? It's the inverse. It's the line of symmetry. You're just switching the... Remember how we find the inverse function? Take the x and the y and flip them and then solve for y? So what I'm going to do here is say this. 0, 1, which is this point, becomes 1, 0, which is that point. 1, 3, which is here, becomes 3, 1, which is there. 2, 9 is way up here, becomes 3, 4, 5, 6, 7, 8, 9, 2, which is there. Okay? Negative 1, 1/3 becomes 1/3, negative 1, which is here. Negative 2, 1/9 becomes 1/9, negative 2, which is there. And if you notice, this is going to come through here and go through that point, and it looks like symmetry. It looks like I just flipped that thing right over. All that I have to do is take my x and y points and swip them. 9, 2, 3, 1, 1, 0. Well, this is that's a tick mark in it. So this would be 1/3, negative 1, and 1/9, negative 2. Okay. Do we remember something called RP? What is an RP? It's a reference point, isn't it? In my exponential, my reference point is 0, 1. Question, what is the reference point of a log function? 1, 0. Because when I flip it over, the easy point to start with is 1, 0. The reason being that anything to the 0 power is equal to 1. Right? Anything to the 0 power is equal to 1. So what else are we going to do here? I want to look at a couple more. Y equals negative log base 3 of x. Now we don't need to graph this thing right now. But what I need to know is remember something called a transformation. What does log base 3 of x look like? It looks like this. What if I put a negative out in the front? What's going to happen?
Flip it.
Flip over, right? And I can't just say flip over. I got to say flip over which axis? The x-axis. So what I can just say here is flip x. Okay? How about y equals log base 3 of x plus 4?
Does that move over left?
That's correct. How do you know that right away? You were right.
Is that magic? I don't know.
4 units in the left direction, right? How do you know that?
You taught us that.
Whenever it's inside the parentheses, it is left or right. And whatever it is inside the parentheses, it is the opposite direction of the sign. And if it's plus 4, I go to the left, which is the negative direction. So I say left 4 units. Now, we say this. Log base 3 of x plus 4. This one is going to be log base 3 of x plus 4. I say them the same. I can say this one is the quantity if you want. Log base 3 of the quantity of x plus 4. Great. Log base 3 of x plus 4. Down or up? I think it's going up.
Why? Oh.
Because the one that's on the outside of the function is not opposite. And finally, my last one here is log base 3 of negative x. The negative is on the inside of the function. It is inside the parentheses. What?
Flip over the y.
Flip over the y-axis is a horizontal flip. Okay, so we can just say flip y. And the last thing that we are going to talk about today, and I'll resume this lesson tomorrow. The last thing that I want to talk to you about today, actually I lied to you. I told you that the only log that can be typed in the calculator is log base what? 10, right? There's actually another base that can be typed in the calculator. Do you remember something from 3-1 called e to the x power?
Yeah.
The natural base used in interest formulas. Okay, this is an exponential. Remember what e is equal to? 2.71828 and so on. That number repeats. Close to repeats, actually. Okay? The natural base is used in interest formulas and some counting principles and so on. I can have log base e. Log base e, but log base e has a name. What is the button on your calculator just underneath log? ln. It's pronounced this. E-L-E-N. And ln, if you take the letters and switch them around, is NL, and NL stands for natural log. So what I have here is this, the natural log of x. That's how we say it.